Assalamualaikum and a very good day, especially for our lecturer, Dr. Hafizi, and my fellow friends. My name is Muhammad Khairul Shazwan Muhammad. Today I would like to present about our mechanical vibration group project, which is a single degree of freedom torsional vibration system. So actually, what is a torsional vibration? Torsional vibration is an angular vibration of an object that commonly occur on the shaft along its axis of the rotation. So for the first picture, we can see this is a spring, K is a stiffness, and this is a mass, the mass donated by N. And for the second picture, this is a shaft, K is torsional stiffness, and this is rotordisc. And the last picture is the displacement angle when we pull down the flywheel. So this is our experiment setup. This is our shaft. Okay, this is our comparison between experimental value and theoretical value for the three main parameters, which is stiffness, natural frequency, and damping frequency. For the stiffness, we got the experimental value from the graph taught with as displacement angle, and for theoretical value of stiffness, we get it from the formula of Kt equal to pi Gd to the power 4 over 32L. And then for the natural frequency, experimental value, we got it from the formula of Wn equal to sec Wd square plus sigma square. And then for the natural frequency of theoretical value, we get it from the formula of Wn equal to Kt Wn sec Kt over n. And the last one is damping frequency. For the experimental value, we get it from the formula of Wd equal to 2 pi over t. And then for the theoretical value of damping frequency, we get it from the formula of Wn set 1 minus zeta 2.
Assalamualaikum. My name is Nur Azalia, MA 112027. Today I will, for this video, I will demonstrate the experiment for our vibration lab, torsional vibration system, and then I will explain about the procedure for our experiment.
Assalamualaikum and very good day to my beloved lecturer, Dr. Hafizi bin Zahari, and my fellow friend. I'm Siti Nursalihah binti Muhammad Rasdi. I will present about result and discussion from our experiment Firstly, I want to show the result for decay rate that we got it from experimental, which is the formula y equal to a e negative sigma t, which is the sigma is the decay rate, and then from the decay rate we will find the damping coefficient and the damping ratio as in the table. We got it. The damping for 200 gram mass is less than 600 mass. Okay, after when we got the damping ratio, we also can find the stiffness from the plotted graph top versus displaced angle. And then by using this formula, omega n equal to omega d square plus sigma square to the power of 1/2. We will got the omega n from the experiment. Omega d we got it from the plotted graph, which is a displacement graph. By using the software, MATLAB software, we take the peak point between this graph, and then we will get the t. For the omega d is actually equal to 2 pi over t, and then we will substitute the omega d inside the omega n formula. Okay, next is the comparison between the natural and damping frequency. Okay, first of all, our parameter is stiffness. There is the stiffness we got from experimental, which is 4.4650, and then the theoretical is 7.407, and then we got the error is 65.89. Sorry, this is because the error in the lab, which is the surrounding error, and then I believe that have another extra force because the friction between the flywheel with the road. And next is for the comparison of natural frequency between the experimental and theoretical. We get 200 gram have a higher value of natural frequency. Then for 600 gram we will get the lower natural frequency. From this experiment, I can say that the increasing of mass will make the natural frequency is decreased. Okay, based on this graph, alright, we can go this. The decay rate for 200 gram is more than 600 gram, which is when the mass is 600 gram, the graph is more, the slope is more high. Okay, then lastly, we compare about the omega d, which is a damping frequency. It's also shown that the increasing of mass will decrease the damping ratio frequency. So for the conclusion today, I will conclude that the experiment is under test system because the zeta is less than 1, then the increases of mass will affect the decay rate because the decay rate will decrease due to the increases of mass. Then the slightly different between natural and damping frequency is shown that the experiment actually is not a damping experiment, but with the surrounding error, it will make this experiment as a damping experiment. That's all from me. Thank you.